Forensic Science Lecture 17-4, Tool Marks and Other Impressions. A tool mark is any impression, cut or gouge or abrasion used by a tool caused by a tool coming in contact with another object. And a careful examination can reveal significant class characteristics, the size or the shape of the tool. Rarely individual characteristics can be found, but they do exist. Usually discernible random nicks or other breaks on the tool that are acquired through wear or just everyday use of the tool cause the individual characteristics. So they do exist, just harder to find usually. Markings are left when the edge of a tool is scraped against a softer surface. So cutting a series of striated lines that reflect the pattern of the tool. In a lab comparison of the evidence marks to the suspect tool, marks are made in the lab so as to perform the comparison. Labs need to create a number of marks from various angles to duplicate as many marks as possible before comparing. Using then a comparison microscope, if there's a significant amount of striations that match in that comparison, then a positive comparison is reached. Problems come in to the duplication process or duplicating the impression that was left at the scene, because there's always going to be different circumstances, different amounts of force, and so on. And so again, it's important that there are multiple marks at various angles to try and duplicate to the best of their ability. If possible, the entire object or part of the object with the tool mark should be submitted to the lab. If that's not possible, obviously, not always, especially on a larger object, a photograph should be taken to scale, and then a cast needs to be made. Liquid silicone is the best to reproduce fine details of the marks, but under no circumstances should the investigator ever attempt to fit a suspect tool into the tool marks. Any contact between the tool and the marks surface may then alter the marks, which then can lead to an inconclusive analysis. The suspect tool and the marks need to be packaged separately and then sent to that lab. Tools and impressions may also contain trace evidence, so special care needs to be taken in order to avoid losing any of this or destroying any of this. But again, at no point should the tool be fit into the mark. At the very least, that could raise serious questions about the integrity of that evidence, and something that may be very important can be thrown out in the court. Before any impression is moved or handled, it needs to be photographed to show all of the observable details of the impression. Side light will aid in highlighting many of the ridge details that might otherwise be hidden if there was no light added to it. Photograph images are considered a backup procedure in case the impression is damaged when it arrives at the lab. Impressions such as shoes, tire, fabric impressions can all provide important information, so nothing wants to be overlooked or left out. And of course, the photographs need to be to scale. If the surface can't be submitted as a whole with the impression, it needs to be preserved in a manner that's similar to the fingerprint lifting method. Other lifting procedures include using what's known as an electrostatic lifting device, and this is great for barely visible prints on colored surfaces, but basically it's a sheet of mylar film is placed on top of the print, and then a high voltage electrodes are placed in contact with the film, and then the charge difference develops the print to the film, which is then lifted and sent to the lab. Impressions in dust can be enhanced through chemical development, very much like fingerprint fuming, superglue fuming we did for the fingerprints. When they're lifting shoe impressions or tire impressions, it needs to be the lifting material needs to be large enough for the entire impression. They can't do it as pieces. Another way that they can preserve impressions is through casting these. So shoe and tire marks can be made in soft earth, dirt, mud, sand, snow, and they're best preserved by photography and then casting. So the series of photos illustrates the steps taken by the suspect, and then the use of Densil stone to cast the print. The cast should be allowed to air dry for 24 to 48 hours before shipping to the lab to ensure that the impression isn't altered at any point. If that casting material is still wet, it can change forms. An impression left in the snow can also be cast, and they use an aerosol known as snow impression wax. And so what they do is they spray 3 light coats of this wax onto the print, and then it solidifies that print. And then it can be cast and removed just like if it was in mud. Chemical enhancements can also be used to develop and enhance a footprint in blood. None of the chemicals that they use deteriorate the DNA within the sample. So the STR DNA typing is still possible. But again, it is enhanced much like that of a bloody fingerprint. So they determined that using these same procedures that they use for fingerprints works just as well as they're looking at shoe or footprints. Comparison of these impressions is only possible once that suspect item is recovered. The value of the impression is determined by a significant number of points of comparison. The uniqueness of such points support both the question and the tested impression originated from the same one and only one source. There is new computer software that assists in the comparison process of shoe prints and tire prints. It's known as Shoe Print Imaging Capture and Retrieval, or SICAR, and it incorporates databases of known and unknown footwear files. So it gives them a good starting point. Impressions can also be searched in suspect and crime databases as well. When looking or comparing these prints, most of the time what they're going to find are class characteristics. Okay, it has to be through careful examination to find those individual characteristics that are formed from the way that somebody walks or how the tire has worn down as it's been driven. But it is not if they're just looking at the class characteristics, they cannot entirely exclude other possible sources. Okay, they have to look for those individual characteristics. Bite mark impressions on skin or food have also been able to prove important evidence in a number of homicide and rape cases, one of which was the Ted Bundy case as well. That is actually what was his final downfall, is his bite impression on one of his last victims matched his cast of his teeth. And what they do is they have a forensic odontologist that compares the bite mark on the victim to the cast of the suspect. And again, if there's a sufficient number of points of similarity, they can conclude that the mark was made by a particular individual, such in the Ted Bundy case. This ends lecture 17-4. There's a quiz next class.